Students, today we will talk about separation techniques. We know in nature we do not find chemically pure things. Very rarely we find chemically pure things. We often call this milk is pure. But what we mean by that is milk is not adulterated or not mixed with water or something. But in chemistry, when we talk of pure things, it will be either a pure element or pure compound. Usually we get mixture of so many things. Even air around us is mixture of gases. Or when we talk of milk, it's a mixture of water, proteins, fats, minerals and so on. So in nature, when we get such mixtures around us, we need to separate the components of them. So the constituents of mixture can be separated using different techniques. And yes, we use many such techniques in kitchen, at our home, or even in the fields, on farms. Usually we have to separate two solids from each other. So if two solids are mixed, for example, you buy grains like rice or wheat and you find there are stones in that. What will you do? You will hand pick stones and throw them out. So that's a separation. Or sometimes we use sieving technique using mesh, and you get separated as per sizes, either grains or stones can be separated based on their sizes. Or in farms we use these techniques called as threshing or winnowing, where the stalks and actual grain are hit against some surface and grain is separated from that stalk. Then using air we blow off that husk and get that grain. So that is separation. Again, one more technique of separation. Or sometimes magnetic materials like iron particles are mixed in some other substance. We can use a magnet to separate such combinations of such mixtures. And one more technique is sublimation. Like camphor can directly jump from solid, it can be heated and it can once again get deposited and can be separated from some other mixtures. This is quite simple. But when solids are mixed in liquids, like take a simple example, you add some soil in water. Soil does not get dissolved. It can be separated using a technique of sedimentation. That means slowly this soil, being it's heavy, will settle down. Then you can decant or remove the water from above, and that is called as decantation. Or sometimes the particles are very fine. They don't settle. They get suspended in water. Then we can bring them together by some technique like using alum. You can use a technique like loading, and once they get heavier, they'll anyway settle and you can decant good liquid out of and let that sediment remain in the base of it. Likewise, if particles can have a better size, bigger size, which can be filtrated, like there could be a filtrate collected and the liquid can be collected in a separate container, and the solids which do not pass through filtration will remain on top of filter paper or filtration, some kind of cloth. So that is one more technique. But if some particles are very fine, which can pass through filters, then you have to use some more scientific technique that is called as centrifugation. Take an example, milk. You have to separate from milk fats to produce ghee or produce butter. Then you can separate that butter or that fat component from milk by centrifugation. Or recently you might have heard that plasma is separated from blood, or RBC are separated from blood. That is done by centrifugation. So in laboratories or in milk related industries, this process is very common. Sometimes like salt is added in water, that gets dissolved. You cannot filter it out, or there cannot be any other method used for that. Then you have to use evaporation. You know that even at sea, the water is collected in some kind of ponds. That pond water is exposed to sunlight, it evaporates, and finally only salt and sand remains in the pond, from which salt is further separated and we get that table salt. Such techniques like chromatography, where dyes are separated using the dissolution in that solvent, or crystallization, where using a small crystal, more ingredient of same element is collected on a crystal. So all such techniques are used to separate solids from liquids. And finally, when two liquids mix with each other, or you have to take out liquid from some impurities, more important is liquid now, you can use some different techniques. Like again, same decantation, if you mix oil and water, you can take out oil because it is lighter, it will be on top of water, you can just take it out by decantation. Distillation, like that liquid is evaporated, that vapors which come up and come out are condensed, they are exposed to some very cold kind of atmosphere and they condense and pure water comes out or pure liquid comes out by distillation. And if there are some liquids mixed with each other, then and their boiling point is little different from each other, then you can use a technique called as fractional distillation and separate out one liquid at a time by changing the heat or rising or decreasing the heat. You can take out different liquids mixed with each other. And of course centrifugation, in the same way you can use even for liquids. So all these techniques we use in our life to separate mixtures. However, don't forget that if it is a chemical reaction and it's a new compound formed, then you cannot separate constituents of that compound because it's a chemical reaction. They are all physical mixtures, and physical mixtures can be easily separated because that process is a physical process. So this is all about to understand what is separation, separating two or more constituents from a mixture, commonly used technique, and I hope you understood it. Let us do some experiments now to know few of these techniques. Students, let us do actual activities of separation technique. The material is there in front of us and a booklet giving all activities together. I will show you all activities one by one. Initially the activities are simple and finally we have to do one handheld centrifuge as well. So get ready, let us begin. We will do magnetic separation as the first activity. We have in this small bottle some sawdust, but this sawdust is mixed with some iron powder. We have to separate this iron powder from this sawdust, and best method will be using a magnet for this. Let us try it out. I am taking a magnet and just bringing it close to this, moving it around, and you will find complete magnetic material from this sawdust gets attached to this magnet. Now we can easily separate it into this watch glass. So we have separated iron dust from sawdust. A first separation in our activities is separating using magnet. Now we'll try out filtration activity. For this purpose, we have this chalk powder. We'll take some water in this container, add some chalk powder into that. You know that chalk powder does not get dissolved in water. It is insoluble. So let us begin. I am taking some water into this container first. Adding some chalk powder into this container it will become a white suspension. I'm just shaking it, so it becomes whitish milky color suspension. The particles of chalk powder are still there, they are not dissolved. We can separate them by using filtration technique. For this purpose, I am using this filter paper. Let us fold it in the middle like this. Take one more fold like this. So, by inserting my finger into one flap, I am opening it. So it forms a cone. I have to put this cone into this funnel. That way this remains in place, but to make sure that this remains in place, I will be just adding some drops of water and pressing it with my finger. So now it is firm into this place. Take an empty bottle, place it here and put this funnel on top of it. This mixture of chalk powder and water is in this container. Let us slowly add it into this funnel. I may add some more water into this so that complete chalk powder will be taken out. Now you can find the process of filtration has already started. Water is getting filtrated. Water molecules are passing through this funnel and getting collected into this bottle. And the residue on this filter paper is nothing but chalk powder. So you have separated a mixture of chalk powder and water using filtration technique. Chalk powder is deposited on filter paper. As this will dry, the chalk powder can be separated or taken out. Water has gone down into this bottle. So that is the process of filtration. This time we'll see how to separate a solid from liquid when that solid gets dissolved in liquid. For this experiment, I have this table salt with me and of course water. You know, salt gets completely dissolved in water, but we can separate that easily. What is the procedure then? First, let us begin. I am taking some water into this, adding table salt in this. We'll just cover its mouth and shake it. So you will find salt is totally dissolved into this. Now if I take this water into this watch glass, this water has salt inside it. It is dissolved in this water. I can place this straightway under the sun, or if you can't find sun, then you can also place it under fan. Keep it for a while. Slowly this water will evaporate and salt will be visible in this watch glass. This will take some time. We'll place it under the fan and we'll see formation of salt or separation of salt from water by evaporation of water. To separate insoluble solids from water or any liquid, there is one more process used. That is called as sedimentation. We will be doing that activity now using chalk powder again. I'm taking this chalk powder into this transparent vial. Let me take some chalk powder into this first. Particles of this chalk powder are heavy. They are heavier than water. So, if I add some water into this, you will find this chalk powder has made this water whitish, or there are suspended particles into this. If I keep this bottle undisturbed for some time, slowly this chalk powder will settle because the particles are heavy. So that's the process of sedimentation. And when this water, which is now getting cleaner slowly, it will become totally clean, and then I can take out this water by tilting this vial and removing or taking out water slowly into another container. That process is called as decantation. So now this is almost settled, water is up, and this sedimentation has already occurred. I can now tilt this a little bit and start pouring water into this slowly without disturbing that sedimented part of. When I feel that there is a possibility of this chalk powder coming into this container, I can stop, or I can use a dropper to collect this water and transfer it here. So chalk powder has remained here, and I could take out water from that. So there are two processes involved. One is sedimentation and decantation. We have done both. We have seen how to separate insoluble solids from liquid. Now when two liquids are not soluble, they are called as immiscible liquids. So liquids are either miscible or immiscible. How to separate two immiscible liquids can be seen now through this experiment. I have taken some water in this clean vial. I am using this oil pouch. Oil and water, they are immiscible. So I am just pouring this pouch into this vial. So I transferred the contents, there is the oil, hair oil, into this water. You can see the red layer of water, oil, is floating on water. Even if I disturb it, it will once again come together and always float on top. So oil is lighter than water, so it floats above level of water. Now I can remove this water and I can separate oil from water by same decantation method. Slowly I can either transfer it this way, the oil can come out, or if it is difficult, then I can use this dropper to pick up this oil and transfer it. So you can see slowly I could remove almost complete oil from this water and could transfer that into this. So this is again decantation method of separating immiscible liquids. Now we will try a separation technique called as chromatography. Chromatography is used to separate constituents of a mixture using some porous medium. In liquid, if there is a colored mixture having multiple constituents inside, these colors can be separated on some material like paper, porous paper, or even a chalk. In this case, the moving or dissolved solution that travels is called as mobile phase, and on paper or on chalk, if it is traveling, that is called as stationary phase. You know, these constituents which are mixed travel through this medium with different speeds. One having smaller particle size will travel faster, so naturally can go up, and those which are with heavy particles will travel slow, so they will reach to a limited height. So based on their heights, different constituent components can be easily separated. We'll do chromatography using two different methods. One paper chromatography and one is chalk chromatography. The first one is with this sketch pen. You know, sketch pen ink appears to be black, but is a mixture of so many constituent colors. These colors can be separated on a piece of paper using this technique. Let us do it. Let us begin. This is a filter paper. You may use even a blotting paper for this. I'll cut a long strip of this filter paper. On this strip, I'll make a dot using this sketch pen close to one end, but not exactly at the end of it. So I have made a black colored dot on this. Let us add very small quantity of water into this vial. You must always clean this dropper before using it for second experiment. So some quantity of water is taken. Now just insert this strip of filter paper into this by dipping its one end into water and let it remain. We'll keep it like this for some time. Water will start rising up and slowly it will take ink along with that, and constituent components of this ink will be separated. It may take little while, but slowly you can perhaps recognize that some different colors are appearing at different levels. So the color of this pen is not exactly a single one which you normally see on paper. It is mixture of so many constituents. So these constituents now get separated on this piece of paper. That is paper chromatography. You can see it is purple or little reddish purple here, and slowly this green color pigment has traveled up. So the upper end you can see green. So this black is a mixture of these all colors, giving it a blackish final result. We will do activity using a chalk and chromatography of food color using chalk. This is a green color. I'm adding this into this bowl. I have taken little water in this. So some food color is added and I'm just dissolving this. So the green colored liquid is ready. Simply put this chalk upright into this. Just make it rest in the bottom and wait. You will find this green color starts traveling and different constituents of this green color, they travel at different heights depending on their molecular size. So you may find yellowish color slowly travels up. It has different speed. It is faster. So that will travel up. Many such pigments, for example, plant extracts, they are also separated using similar technique, that is chromatography. This is a common technique. What we are doing right now is a liquid chromatography. There could be gas chromatography as well. After 3 to 5 minutes, you can find that yellow is separated from green. So it's a mixture of two constituents here, green and yellow, making it deep green. Now we will try a separation technique called as chromatography. Chromatography is used to separate constituents of a mixture using some porous medium. In liquid, if there is a colored mixture having multiple constituents inside, these colors can be separated on some material like paper, porous paper, or even a chalk. In this case, the moving or dissolved solution that travels is called as mobile phase, and on paper or on chalk, if it is traveling, that is called as stationary phase. You know, these constituents which are mixed travel through this medium with different speeds. One having smaller particle size will travel faster, so naturally can go up, and those which are with heavy particles will travel slow, so they will reach to a limited height. So based on their heights, different constituent components can be easily separated. We'll do chromatography using two different methods. One paper chromatography and one is chalk chromatography. The first one is with this sketch pen. You know, sketch pen ink appears to be black, but is a mixture of so many constituent colors. These colors can be separated on a piece of paper using this technique. Let us do it. I have removed these nuts from these bolts. You will find there is a cell holder with a switch and two wires. First, let us remove these insulations from these wires and roll these strands together in your finger so they make a single thread. Same here, I'm just rolling it like this so they become a single thread. Now this cell holder has two holes. I'll pass these bolts from these two holes and then pass them from this batten as well. And lock nuts from other side so as to fix them. So I am fixing both the bolts to this batten. You don't need a screwdriver for this. It is quite simple. So this is done. Now to this batten, I'll be fixing this toy motor. This has these two small holes where I'll be inserting these two wires. It's metal part of wires, obviously. That's the reason we had brought them together, these strands together, so that single thread can be easily inserted into these two holes. So pass it through this hole and twist it so this joint becomes a firm and stable. You can see these two wires are inserted in two holes of this motor. The wires are properly twisted. Then on the other side there is a double side tape. I am removing its yellow release paper slowly from this and placing this motor here, keeping its shaft above level of this batten, so it can easily rotate. But this joint is not sufficient to keep this motor in place, so we'll use this cable tie or locking strip. You know that when you pass this locking strip and it becomes a, this is wrong because it is not making any sound. I'll have to turn it over and insert it, so it will make a specific sound. Just listen to it. And just lock it like this. So now this won't fall. This is a permanent joint. I can cut this extra portion. So this one part is ready now. We have these two vials and we have fixed these two hooks on top of them. In one vial, we'll take mixture of oil and water, and in the other vial, we'll take mixture of water and chalk powder. So I'm taking oil into this. So oil is transferred into this. I'll also take some chalk powder into this, and then we'll add water in both of these vials. I'm adding water in both of them. And also in other vial. Let us lock them. So your experimentation setup is getting ready. Two vials with two mixtures. Then we'll go back to this assembly. We have this pulley structure having two holes. One hole is here, other hole is here. And we also have such big hooks. By pressing it like this and rolling your fingers this way, you can insert it into this pulley. Both. On the other side also, we'll just start pressing it and rolling it. And this also is locked. So these two hooks are ready to this pulley. Now this pulley can be easily fixed on top of this shaft. This is a plastic bush which snugly fits into this, and so this is your rotating shaft. Now I need two such double A type cells. These are not provided in the kit, so you will have to get them before you start this activity. In this cell holder, this flat surface of the cell should be towards this spring, that is the negative side towards the spring, and positive side here. Same thing, this flat surface towards this spring, that is negative side, and it is here. So you can operate switch to turn it on and off. Now I turned it off. Let us shake this a little bit first, so this gets mixed, and tie it here. Just hang it here. Similarly, shake it here, this like this, so it becomes a complete suspended particles or a mixture, and these two are now suspended to this. If I start this, the action of centrifuge will begin, and heavy particles will settle at the bottom and lighter particles will come up. Let us start. So it has started spinning. I am holding it firm in my hands. Let it spin for few minutes, maybe 2 or 3 minutes. Usually in real life centrifuge machines, the speed is at least 4,000 to 5,000 revolutions per minute, that is RPM. And those which are with high speed, then the revolutions per minute, the RPM is as high as 15,000 to 20,000. So at that speed, take an example, when blood is spun like this, there is a spinning action for almost 30 minutes. Then RBCs, plasma and other constituents of your mixture, that is blood, are separated. So that is the normal way of centrifugation. Now I'll just turn it off and see whether the two parts are separated or they are yet to be separated. Let it stop. Take a look. You will find that in the two vials, the heavy chalk dust has settled like a sedimentation, and light oil has come up, and heavy water has settled down. So that's the way centrifuge works in real life.